This will be a way to make people think you're smart. I'm going to give you 737 nanometers, and what we're going to do is find the energy of electromagnetic radiation with that wavelength. It'll be really easy to do. So the first thing that we need to realize is that we can't calculate energy directly from a wavelength, and so what we need to do is we need to get the frequency off of that wavelength, which is simple because the speed of light, but remember it's really the speed of any electromagnetic radiation in a vacuum, is a constant, 3.00 times 10 to the 8th meters per second. And we just plug that in. Now, the problem is the speed of the electromagnetic radiation constant is in meters per second, and we've got nanometers, but that's easy because remember, hundreds of nanometers are translated to, well, they're converted to 7.37 times 10 to the negative 7th meters. Ooh, kind of got a little bit of bleed through on my paper there, sorry. That's my last video. So 737 nanometers becomes 7.37 times 10 to the negative 7th meters, which is important because that way it plugs directly into the equation. Now I'm going to go ahead and divide C over the wavelength equals the frequency. You can do that too. That's easy. C over the wavelength equals the frequency. 3 times 10 to the 8th meters per second over 7.37 times 10 to the negative 7th meters equals the frequency. I'm going to put my parentheses around it. 3 times 10 caret 8 divided by parentheses 7.37 times 10 caret negative 7, boom, boom. And I get 4.07 times 10 to the 14th hertz. Now, a lot of people will want to stop there and say I'm done. But if I'm asking for the energy, that's not the frequency. We can use the frequency to find the energy. And we remember our other formula is E equals H nu. H in this case is the constant, 6.626 times 10 to the negative 34th joule seconds times 4.07 times 10 to the 14th hertz. And hertz is kind of like a per second. So we'll take that answer times 6.626 times 10. Boom, boom. And I get 2.70 times 10 to the negative 19th joule. And don't we seem extremely, extremely smart? So we use the wavelength to find the frequency and the frequency to find the energy. You can go backwards on that too. All I need to do is find a clean sheet of paper, which is right here. And so, these numbers, I just pull them out of my head. There's nothing. So if I get 3.83 times 10 to the negative 19th joules, that's an energy, I can go backwards and get the wavelength out of that. So I can't get the wavelength directly from the energy because wavelength isn't in that formula that we have. So I got to go back and get the frequency. So E equals H nu. I have the E, so I'm dividing both sides by the H to get that frequency by itself. E over H equals the frequency, 3.83 times 10 to the negative 19th joules, divided by 6.626 times 10 to the negative 34th joule seconds. Put them parentheses around there and you never go wrong. That's going to get me a frequency, and that should be a pretty big number. If you start out with something times 10 to the negative 19th for energy, your frequency is usually something times 10 to the 14th. 83 times 10 caret negative 19 divided by parenthesis. And yeah, I got 5.78 times 10 to the 14th hertz. And I can go right back into C equals lambda nu. See, we're just working backwards from what we did in the last video. And I know C is a constant. And then if I divide it by the frequency, I will get the wavelength. So I can take this and put it in there because that frequency is the same thing as that frequency. And then divide it by 3.00, divide 3.00 times 10 to the 8th, divided by the frequency, 5.78 times 10 to the 14th hertz. And then and that gives me 5.19 times 10 to the negative 7th meters, or 519 nanometers. And if you can follow that, you can do any of those sets of problems on the lecture sheet for practice, and then there is another set for kind of homework grade type deal. So I hope you enjoyed doing some problems.